of gas laws, right? And I said first we'll do some review on the gas laws numerical problems, and I'll test you on gas law problems. But what I have realized, we have to do some activities, and if we start working on those problems, we might not have enough time to finish all of these activities, right? So what we'll do, we'll actually work on this. We have got some activities to do, and I'll distribute what you expected to do in a while. So we'll be working on this. Next class, we'll have review on numerical problems also. Then you can ask if you have any questions related to numerical problems, right? And we have to cover one more concept on gas law. So technically we have 3 classes next week. First we will cover numerical problems of gas law and ideal gas equation. And then we have the following class as review. And the last class next week will be test on gas. So this, I mean, you can use this weekend to start reviewing for yourself. And I will probably share a review packet, but I'll say that on Monday only. So you already got the learning goals for this chapter, right? So start looking at the learning goals. You have to go over one or two concepts, but you should start preparing for the test now. You have got all resources. I have posted all quizzes already, right? I'll post the answers for the worksheet that I have given for numerical problems. You should have all the resources that you need for this unit, right? So start preparing for yourself and don't always wait for the review packet, right? But though I will say the review packet on Monday. Okay? So today, what we're going to talk about the real life application of gas behavior and gas laws. Pressure is of course, but what is gas pressure? Okay. Laura?
The collision of particles with themselves and
Collision of the particles, gas particles that creates the pressure. Okay. And you know how atmospheric pressure changes when you go to higher altitude, right? So what is atmospheric pressure at sea level? Johan?
1 atm.
1 atm, right? What happens to the atmospheric pressure as you go to higher altitude or higher elevation?
Decreases.
Okay, guys, don't answer unless I point out the question. So generally, I'll pick a person to answer the question. Okay. So what's the relation between pressure and volume? Inversely proportional, right? Okay, I'll ask next question. At constant pressure, what's the relation between temperature and volume? Pressure. Okay.
Are you talking about the particles?
So what happens to what's the relation between temperature and volume at constant pressure?
I wasn't here last class.
It was a question from previous class.
No, it was 2 classes ago.
No, I don't know.
I mean,
I don't know.
As the temperature decreases, volume losses.
sorry?
As the temperature increases, volume losses.
Okay, so basically the directly proportional, if one increases, other one also increases, right? So basically, in today's activity, what you do, we have learned these relations, right? So basically, we'll see how this is useful in our daily life. We'll do some small activities here, and you try to relate that with your daily life activity, and you have to explain. So what you're supposed to do, we'll have 7 stations. I'll do like 7 activities. Basically, you all come and observe those 7 activities. After that, I'll assign you guys as a group of 3, and you have to work on one activity, and you have to write the reason. Why does that happen? You have to explain. You have to start giving the reason for that phenomenon. And detail is actually being shared here as a rubric. Okay. So I'll distribute this handout in a while. Please go over this one and how to write. You have to basically write a report on Google Docs. So we have the same Google Doc, but you will be writing in different. You will have to write on the report on different activities. Okay. So each group will write reason, or each group has to explain one of the activity with explanation, with the reasoning, right? And I'll decide that once you see all of those activity, which group is doing what, all right? And follow rubric for the grading, because it will be graded, right? You're not writing a proper lab report on this. You'll be using the same Google Doc, and everyone will be working in the same Google Doc, but on different sections, right? And you have to write down the name, so that way I will know like who was working on which part, right? But at the same time, you also have to look at others' work, because you guys will be tested on real life application of gas laws next class based on what you have written in the Google Doc, right? And how many of you are familiar with how to use comment feature in Google Doc? So you know how to use comment, right? Because once you do, you also have to do peer evaluation. So you have to look at the work of other group and you have to comment on that, right? Because though you will be writing vision for only one of the activity, when you come next class, you should know reasoning for all of those 7 activities. Right? That's why you have to also look at others' work. Right? And in the rubric, you will also find out. I have actually made different categories, and there is a percentage. So this is how I'm going to grade. And there is follow-up test. Basically, after whatever you learn today and follow the Google Doc, next class there will be small test on this, which will count for 25% of the overall grade for this activity. Okay, this is basically try to measure how you can apply the concept that you have learned in your daily life. Alright, so first I'll distribute.
Why is my back?
So this is test number 1, very simple activity.
Go
What
around the
happens
other
is like
side there.
I'm going to put create some bubble here by using this dropper, and you can see the size of bubble as it goes up will increase, right? Or it becomes bigger and bigger.
Oh god, that was short.
Now you can see this. Do you see? Once it's created here, I mean,
It's a phenomenon.
Oh my god.
It goes up. Wow. I have to report on this.
okay, this is very simple activity,
Plate.
right? Anyone has any question here?
Some are hard. Yeah, the burning plate.
Can you feel it?
It says he touches the burning plate, it doesn't affect him.
These activities are simple, but you have to come up with good explanation. Why does it grow? Okay. So now you can think, and you can relate this activity to lots of things. Even like whenever you drink something using a straw, how it works, right? So it's very simple activity, but coming with good explanation.
This is what they do when you have to feed a baby.
Well, that was a bit.
Squirt it on, bro. Squirt it on. Squirt it. But now you have to come with explanation. How is it possible for us to fill this syringe? Right? And also think of like when you use straw to drink some drinks, how is it possible? How does it work?
Inappropriate.
Okay. All right.
Yeah, sure.
So let's go
The
to
water bag one.
Yeah, put it.
yes, third activity.
Yeah, that's why. Feels not down.
It's leaking.
Okay, we try to.
It should expand actually, yeah. What happened? Now it's working, expanding.
there we go.
It's expanding.
Yeah.
Gonna pop.
Okay, I'll stop. Right now, imagine what happens to the hot balloon. Sorry, helium-filled balloon as it flies high. Right? You have to come with the explanation. What happens, which is basically similar to what happened just now.
Because as it goes high, the atmosphere.
You have to
Yeah,
write
no,
that
question.
region.
So
Reuse.
Now,
Keep it with you.
you're writing that in the report. So we'll do some activity.
I was trying to keep going. Sorry. I'm sorry.
And on to the next one.
You can try real hard, it won't work.
He's the only one that can do that.
Water jar and dentist.
Joey, man. Second time.
Hey,
In math class. Joey. It'll expand.
It'll expand.
Expand.
You didn't put it.
Expand.
Or it covered.
If it expands, I would have had it.
What did I put in a yarn?
Oh, magnify.
There you go.
yeah, it's actually expanding, I think.
Yeah, it's expanding. It's
It
expanding.
is.
Yeah, it popped up. One part popped out.
Yes,
Yeah.
one pump.
Bubbles come from the bottom.
You can see it bigger. It's bigger, not because it's expanding.
Boom, that touched.
Why don't you rotate it the other way around?
It's not working.
Yeah, there you go. If you rotate it the other way around, yeah.
Wait, do you have to like
be,
squish it a
But it
little?
doesn't. Is it on manual focus?
It is on manual focus.
It's very good.
Okay.
Too late.
We're gonna break the
Most of it's
computer,
alright.
just like last time.
Mr. Best, you have to like squish the ball before you
Yeah,
put that ball.
You didn't even know what that means, right?
But if you see like one part, it was.
It popped. I saw one part did pop out.
I'll try for the next one.
That's too. It could be too close.
Yeah.
Now you see this one. You guys look at this one.
Look closely.
Oh, yeah, sure. It goes ping pong.
So what's happening the other way?
Keep on.
What? Your mom.
My mom is not that
Guys, stop. You need to be focused here.
Your fault?
It's starting.
I think the water's gonna
Don't pop.
You silly willies.
Not popping, like it.
Joey, please tell us.
I was actually interested in Joey's response. Now, did you see?
Yeah, it's getting.
It's good.
Oh. It when someone steps on a ping pong ball.
This is what you can do.
Well, I guess
But hot
Heat it
water.
in water.
theoretically, but
But it'll go back.
I think it's the surface, what it's made out of, is too strong. So it could have more pressure inside than out and still be okay.
Sorry, but
It's very itchy.
very itchy. But did you see a little bit like the one here?
Yeah, yeah.
Oh, it's hot. Don't touch
How about you shut up? Stop.
I knew you.
I don't think we had.
I'm such a lucky.
I don't think we had.
I'm blushing.
Yeah.
Are you going to dig onto the
More spring. It twisted, doesn't it?
One more sponge, not that.
If you don't have glass, would you please
Mr. Depeche, the cans are on fire.
The Coke can is on fire.
Yeah, you can think that. No.
Okay, so basically you can see, I can see some steam. I put a little bit of water here and heat it for a while, and now you can see some steam here.
As it
See what happens?
550 degrees.
On the surface of the heater, but not the water.
Okay, so I'm going to put, see, it has got the opening here, right? And I'm going to dip this can into the water.
Oh.
Oh,
Oh my God.
I'll just do that.
Never goes in with the water.
I didn't cross, but like I put it inside and
It's cool.
That's
Wait, can you do
right?
Why'd you do it? Can you do it slower?
Hey, do it slowly.
like
do it slow.
That's kind of.
Do it slowly.
No, okay. That's not gonna. Why can't you put it in slower?
Step back. Slowly cycle.
Do it slowly.
But like you have to do it fast.
You have to do it fast.
Yes.
quickly.
Don't cross. Yeah. Ready?
Failure.
Oh no! Next time.
Fail. Okay, watch me and then I'll come.
So the best was try.
You have to flip it over. You have to flip it over.
Yes.
Boom, boom, you get it.
Want me to do this?
Yeah, go, boom, go.
Prashant.
Come on,
Prashant, feed us on. Boom should do it. Boom should do it.
Boom should do it.
Just don't throw it.
Yeah.
I don't want to die.
I know. Prashant, I should be right behind you.
Yes.
How are you feeling that?
How long do I have to wait?
Alright, boom, your turn.
Start steaming from you.
Oh, come on.
Okay, so these are like activity and you watch 2 YouTube videos. Anyone wants to try?
I want to be you.
Yeah, yeah.
Ooh, YouTube video.
Random.
You know.
Why can't we do this? How do we do this?
You know what, Mr. Depeche? Compared to this class.
You should do this at school.
What's the water thing?
It's good.
Oh, so perfect.
Well, why didn't we do this with you, man?
For safety reasons, obviously.
No, this school
The school not afford this.
Static. What's static? Well, you don't get static. I want to see it in full flow. I mean, full system.
The fire battery
You have to come to the conclusion. That's your job to find the solution
for each and every one.
The hammer is the primer, causes an explosion of flame.
Oh, that's fucking good, man. Yeah.
Oh, is that what happens?
Yes. How it works? Well, that's not what happens.
Yeah, I didn't know anything about that.
When the barrel spins, it has an accurate spin.
Yeah, no, I'm holding it fast.
Wow.
Okay, let's roll this once more.
I think so.
The second one is Charles' book. What's the other one called?
Well, you better have a look.
He's lost. He lost it. He lost it.
I mean, it was 2 classes ago.
Because they can't get their voices.
You were there, you were not there, 1 class.
They got big.
Such a good That was 20 minutes, 35 minutes.
By tonight? Okay. So let's make the due date to write up the reports tonight. Okay. So you have to finish report writing by tonight. And once you finish report writing, then only you can start commenting. You cannot start putting commenting now, right? So that's why we have to come up with like a specific due date. So tonight you finish report writing and start commenting on each other's work. And the purpose of commenting or doing peer evaluation is when you come next class, you should know explanation for all of these activities or all of this phenomenon. Right? You cannot do all of this at once. That's why I assign each group to do one activity. But when you come next class, you should understand you should understand the phenomenon of this one. And also, once you start putting this report, I will also check the work. Because I also have to see if you have written correctly or not. And I also put my comment there, if there is any detail. Does it make sense? So that way, you have to prepare. And in that way, like, you know exactly what's the reason for those activities and those phenomena, and you should be able to apply that in real life. So when you come next class, you'll have one small formative assessment, which is basically the last section in the rubric you'll be tested on, right? So I'll give 3 questions, and you have to write independently, and you have to answer those questions independently yourself.